Have you ever, been really frustrated by software that just buckles under pressure?
Oh, definitely. Like a website grinding to a halt right when you need it.
Exactly. Or an app crashing during peak use. It happens all the time.
It really does. And that kind of experience often points to a need for testing that goes way beyond just checking if features work.
So, what are we diving into today to understand that better?
Today, we're looking at something called multi-stage integration builds. It's a concept explored in the book Project Management for Project Managers by Orlando Casabon. It's all about making sure software doesn't just function, but performs well, especially under stress.
Okay, multi-stage integration builds sounds complex, but basically it's about making software more robust for the real world.
That's the core idea, yeah.
Mm.
It involves running specific additional tests. So we're talking about things like performance testing. How does it handle lots of users?
Load testing, right?
Load testing, exactly. And also stability testing. Does it stay reliable over extended periods? These are extra checks, deeper dives than your standard functional tests.
Okay, so these are additional tests. Why not just lump them in with all the regular testing? Why have separate stages? Seems like it might complicate things.
Well, the main reason is time and resources. These
Uh,
performance and stability tests, they can be really, really time consuming.
uh,
If you ran these super intensive tests on every single build, every time a developer checks in code, your whole development pipeline would just grind to a halt.
okay, that makes sense. You'd lose that rapid feedback developers need.
Precisely. You
Uh-huh.
need that fast cycle for basic integration, making sure the core pieces work together. Think of it like an initial quality check versus a really rigorous long-term stress test. You do them at different points.
So these tougher, longer tests happen later or maybe in parallel.
Often asynchronously, yeah. That means they might run overnight or in dedicated machines separate from the main faster build process.
So development isn't blocked.
Exactly. The main team can keep moving, integrating features, fixing bugs, while these more demanding tests run in the background, ensuring the system can actually handle real-world conditions without falling over.
Gotcha. So it's not just about having any slow build or testing everything totally separately, right? There's a strategy here.
Absolutely. It's very deliberate. The point isn't just slowness for slowness' sake.
Hmm.
And you don't want to run all tests separately because then you lose the benefit of seeing how integrated parts perform under load.
Right. You need to see them working together.
hmm The multi-stage approach lets you target these specific, heavy tests, performance, load, stability in a dedicated stage, often after the initial integration checks out. It's focused.
So, for everyone listening, the key idea is that these multi-stage builds are a strategic way to make sure software is truly reliable by adding specific, demanding tests for performance and stability, often in a separate, slower process.
That nails it. It's that extra mile for quality, focusing on the things that really impact the user experience when the system is under pressure or needs to run for a long time. The stuff that's make or break.
It really makes you think about past frustrations with software. Considering how critical performance and stability are now, what's maybe a real-world example you've seen where you thought, wow, some better load testing could have prevented this? Something for our listeners to chew on.
That's a great question to ponder. Those moments really drive home the value. And, for anyone wanting to dig deeper into this specific practice and other vital project management techniques, we definitely recommend checking out Project Management for Project Managers by Orlando Casavone.